Okay, so for headlock avoidance, we have two algorithm, that is the resource allocation graph algorithm and second is the bankers algorithm. So in today's session or in today's videos, we will learn about the resource allocation graph algorithm. Okay, so that is resource allocation graph algorithm. So we'll learn about this algorithm in today's video, that is resource allocation graph algorithm. Okay, so normally what we have in is the request stage and the assignment. Okay, first we'll consider one diagram. Okay, the resource allocation graph. Okay, consider we are having two processes P1 and P2. Okay, and we have two resources R1 and R2. Okay, imagine this is the arrow in this direction and this arrow is in this direction. It means that process 1 is holding the process 1 is holding the resource 1. Okay, and process 2 is requesting for the resource 1. Okay, so the main concept behind this diagram is to show the different types of edges which are used in the resource allocation graph. Okay, so this is the dotted line, arrow is in this direction and the arrow is in this direction. Okay, so in resource allocation graph, normally request stage, the one is request age, second is the assignment age, and the third one is also used. In addition to the request and assignment age, we have a new age, we call it as a claim age. Okay, so the request age and the assignment age are indicated by the solid lines. Okay, but the claim age is indicated using the dotted line. Okay, so this is the request age this is the assignment age and this is the claim age. Okay, so for example the claim age, that is if the process is requesting or claiming for the resource, indicate that for example if this one, for example this process I indicating RJ, it means that it indicates that the process P may request resource R at some time in the future. Okay, what it indicate? It indicate process I may request resource J at at some time in future. Okay, so it indicate this one. Okay, so this claim is shown by the dotted line in the figure. Okay, it show the deadlock avoidance with the resource allocation graph. When process pi requests for the resource, so what will be the cycle? First try to understand. Okay, first of all the journey start with the claim age. Okay, so whenever whenever any process wants to request for any resource, then first of all it has to show with the help of the claim ages. Okay, so first the claim age will be shown. When process request a resource, the claim age is converted into the request age. Okay, when the request age, when the resource is released by the process, the assignment age is reconverted to the claim age. Okay, so just try to understand. First the claim age will come. Okay, you can see the example over here. P2 is claiming for the resource R2. Process 2 is claiming for the resource R2. Okay, it is claiming that in future, at some time in future, it may require R2. Okay, when actually it required the R2, then this dotted line will be converted into the solid line and the age will be called as the request age. Okay, and after the request, if the request is granted for the any process, for example we'll try to learn the same example, that is process I requesting, first of all the claim age will come. Okay, so this is a claim age for the resource J. Okay, so this is the process and this is the resource. Okay, now try to understand clearly how the journey is going on. Okay, so first of all we have shown it using the claim age. Okay, the first journey is the claim age. Okay, so process I may request in future at some time the resource rj. Okay, after some time, if it has a requirement of the resource rj, then this age will be converted into the solid line. So this age will be converted into the solid line. Now it is requesting, it was the claim age, okay. After some time the dotted line will be converted into the request line. Now it is requesting. Okay, so if the request is fulfilled, it means that the resource is allocated to the process. Okay, after use or after execution, after requesting, if the request is fulfilled, then this solid line will be converted into the assignment age. Okay, okay, see how the things are going on. First it has claim, after claim if it has a request, then it will make it into the solid line and this age will be called as the request age. Okay, after requesting, if the request is fulfilled, then it will be converted into the assignment age. Okay, after assignment it will start execution and it will start using the resource. Okay, after completion of the access of the resource, it will release the resource. Okay, when the resource is released by the assignment age, when the resource is released by the process, the assignment age is reconverted into the claim age. Okay, so again, to which one will come? So this is the, I can say this, the claim age is the first stage. Okay, the request stage is the second stage, and the third one, assignment, is the third one. Okay, so 1 2 3, again after assignment, after releasing the resource, again it will be claimed. Okay, so 1 2 3, 1 2 3, it will goes on. Okay, so before process start executing, all its claim age must appear in resource allocation graph. Suppose that the process pi request resource rj, the request can be granted only if, we need to make sure that, note down, for the same situation or for the same condition, the request can be granted, the request can be granted only if converting the request age to assignment age does not result in the formation of cycle. Okay, so whenever the request stage is being converted into the assignment age, then we have to make sure that there should not be formation of cycle. Okay, so if the cycle is formed, then deadlock will occur. Okay, what will be the result of this formation of cycle? It will be result deadlock. Okay, and we are avoiding the deadlock and we are preventing the deadlock. Okay, so we don't have to form the cycle. Okay, so in order to not to form the cycle, we have to make sure that whenever these different types of ages are converted, especially if the request stage is converted into the assignment stage, then we have to make sure that there should not be a formation of cycle. Okay, thank you. So it's all about the resource allocation graph algorithm, and resource allocation graph algorithm is mainly used for deadlock avoidance. Okay, thank you.